Cambridge AS Chapter 8 Databases Part 2 Normalization. It is very important to organize your tables in the relational database in the best manner. If you organize all tables in the best manner, then you will never have any duplicated data. Any data that might be duplicated, instead of writing it twice, you create a table for it, you create a primary key for it, and you link it with other tables. With other tables. Okay? So, I would like to split the data as much as possible and create as many tables as possible. Every table must have one primary key, hopefully. Okay? If it has partial primary key, because sometimes you need to link two fields together to have uniqueness. You need to add two fields together to have uniqueness. I would like to avoid this. And I would like no duplicates of data. And I would like all relationships must be one to many. All relationships must be one to many. Then the data is normalized to the third normal form. This is the best. Okay? So if I can, because sometimes data is really unorganized. We say it is in normalized form 0. 0 normal form. And I will show you an example where we have repeating groups. When we have repeating groups, we will say that this data is really unorganized. And when we avoid the repeating groups, I will show you what is meant by repeating groups. This is repeating groups. This is a table that has repeating groups. Because it cannot be where is a record? Where is the record? Is this a record? So you have to extend this line and extend this line and repeat Tom 6 San 3 times, and this will be a repeating group of data. If data looks like this, it is really unorganized, and this is in 0 normal form. If you remove this, it's going to be in the first normal form. And you improve it more, and it becomes in the second normal form. And you improve it more, and it becomes in the third normal form. And they ask about this. Let us go through the explanation and through as much examples as possible, because this normalization thing is not very easy. However, if we train on the most recent questions, you will understand what do you need to do exactly. Okay? So, relational data normalization, relational database can help reduce data redundancy. I don't want to have any data redundancy. Each record or piece of data is stored only once and is referenced by a primary key. Every table must have its own primary key. Data is stored in individual tables, and the tables are linked by relationships. I would like all the relationships to be one to many. The proper use of primary key and foreign keys, and by enforcing referential integrity. We have been through this. What is enforced referential integrity? When you delete a record, other corresponding records in the other table must also be deleted. Otherwise, they refer to nothing. If you update a record, other records referring to that record must also be updated. Okay? And going through the normalization process, will remove any data redundancy. This is exactly what we want when we talk about normalization. Normalization is a design technique for constructing set of table designs from a list of data. You may be given some random data, and following the normalization process, you construct a set of table designs. It also used to improve the existing table design. Okay, let us read those three stages. And if a database fails the first stage, that means it's going to be in zero normal form. For a database to be in the first normal form, there must be no repeating groups of attributes. What is meant by attributes? Attributes mean fields. Okay? You study it like this, and I may say field. Okay? So no repeating field. Okay? Items do not repeat. I showed you this is a table with repeating attributes, because items here have to be repeated because this is not a complete record. Okay? So if it has repeating groups, then it is in the zero order form. For a data, let us say step number 1. For a database to be in the first normal form, there must be no repeating groups of attributes. Okay? For a database to be in the second normal form, it must already be in the first normal form and contain no partial key dependency. What is this? I will tell you. Or no multiple dependencies. Sometimes they call it transitive. Let me tell you about. Sometimes you have a table and you cannot have a primary key for it. You need to join two fields to become a primary key. Then some of the data will depend on one primary key. Some other part of the data will depend on the other primary key. So you have then partial key dependencies. Okay? Then it's going to be, if it has partial key dependency, it is in first normal form and fails to be in the second normal form. If it has no partial key dependencies, then it is in the second normal form. For a database to be in the third normal form, it must be in the second, which means it doesn't have any partial key dependencies, and all attributes must be fully dependent on the primary key. Everything relates to the primary key. For example, student, if you put the primary key, you find the record. And the name for that student depends on the primary or the ID of that student. His first name depends on his ID. His last name depends, because it is data about one person. So when you find the primary key, you get all the data about that person. Okay? So his telephone number, his home address, all his personal details belong to the primary key. If some data depends on something else other than data about a student, then you have not all data fully dependent on the primary. Okay? Okay, let us study this because you get them in that form. So remove any partial key dependencies. This is from one normal form, 1NF to 2NF. Okay? Remove any repeating groups. This is from 0 to 1. Remove any non-key dependencies. This is from 2 to 3. Okay, study this very well because the fine description of the first normal form, the second normal form, the third normal form, you can only find them in the TOS papers. Okay? This description, first normal form, description of this, No repeating groups or repeating attributes. Okay. Second normal form, all attributes must be fully dependent on the composite primary key. You have a problem. If you have a composite primary key, it's going to fail to be in the second, because then you have partial key dependency. Okay? So all attributes must be fully dependent on the primary key. If it is composite, then you will suffer from partial dependencies. Okay? Third normal form. All attributes must be fully dependent on the primary key, which means it is in the second normal form. No other attributes, no non-key dependencies. This means it's moved from the second to the third. No transitive dependencies. Okay, let us go through examples because we need to learn this topic. An owner owns houses that people rent from him. He has a database that stores details about the people who rent houses and the houses they rent. The database house rental, so this is the name of the database, okay, has the following structures. You should understand from this the structure of the database. This is the table name, this is the table name, this is the table name. These are the fields or attributes in every table. The one underlined in black is the primary key. So customer ID, first name, last name, date of birth, email. House, you have house ID, house number, road, town, bedroom, bathroom. Rental, you have rental ID. Then customer ID and house ID. This is very well designed database. I think it's gonna be in the third normal form, because customer ID links to customer ID using one-to-many relationship. House ID links with house ID using one-to-many relationship. And this is the retail rental ID. You don't need to bind these together. And monthly cost and depends, everything depends on the primary key and no partial key dependencies. So the term field is a column or attribute in a table. Example, customer ID is a field. Okay, entity. What is entity? Entity is something the data is to be stored about. Entity is going to be a table. Customer is an entity. House is an entity. What is a foreign key? Here, this is a foreign key because it links to a primary key. Here is a foreign key because it links to a primary key. So you have customer ID, house ID in the rental as foreign key. Okay, the database house rental is in the third normal form. All fields on all tables are fully dependent on the primary key. And no other fields. For example, all fields in the customer table are fully dependent on the customer ID. So in the customer ID brings first name, last name, date of birth, and email. So that was an example, and they ask you about the degree of normalization, and you have to say this is in the third normal. Another example. The car rental database is not normalized. This is another database. The current database design, you have booking, you have customer, okay, car registration, start date, end date, car model, car color, customer first name, and here customer first name, customer last name, email, telephone. So you think linking is on the customer first name? Okay, So it is not normalized. You cannot link using the first name. A normalized database design for this will be in the third normal form. So booking, you will have a booking ID instead of car registration, because booking, you will have a booking ID. And then car registration, customer ID, start. So see, we have a customer ID. Instead of linking using the customer first name. And then we have a car. We are splitting this into two tables to be normalized. Okay? So in the car, you have the car registration number. And it is linked into here. Okay? And then car model and car type. So car color, car model depends on the car rather than on the booking. And this is car registration. Customer will have a customer ID because you cannot link on the customer first name because it may repeat. Okay? So customer ID, customer first name, customer last name, email, and telephone. So you were given a non-normalized database and you were asked to rearrange the database and to normalize. Okay? Let us go through another example. This example is really big, rather complicated. Let us go through it a little bit fast. A database is designed to store data about student in a college. Maybe maybe it's, let us make things simpler. Let us study this and skip that. Okay? Okay. So now we had an idea about data normalization. Let us talk very few about other topics, and then the chapter will be about to finish. Database administrator. The database administrator is a person who uses the database management system to customize the database to suit user and programmer requirements. So these are the tasks performed by the database administrator. Issue username and password to stop unauthorized access to the data by using strong password and changing password regularly. So he is responsible about security. Set up access rights and privileges. Who can see what table? Okay, so that only relevant stuff or certain usernames can read and edit certain parts of the database. Customer rights can be read only, full access, or read and write and delete. Okay, so the database administrator decides level of access. Create regular and scheduler backup. It is very important to protect your data from accidental loss. So one of the tasks of the database administrator is to create backups, regular backups. Okay, and keeping backup in another place. Okay, encryption of data to protect its privacy. Definition of different views. We will study about views, who can see the data in what form. And this is a benefit of using database. Definition of different views. Composed of one or more table. Controls the scope of data accessible and authorized user. Also monitoring and logging of activity by the creation of an audit or activity log, and record the use of data. Okay, So these are the tasks performed by the database administrator. Okay, let us talk about the database management system itself. Okay, we have to talk about features, and I think the only thing left is the structure query language. This is very interesting thing I will teach you about, and the chapter will end very soon. The chapter will end. Okay, okay. Database management system. The database itself, the program itself. Data. So, for example, the Access, Microsoft Access program. Okay, database management system is software that controls access to data in a database. For example, Microsoft Access. The database approach, we discuss the file-based approach or the database approach. We discussed that in the first session of the database chapter. It is vital to understand that a database is not just a collection of data. At least it has to be normalized in the third normal form. A database is an implementation according to the rules. The basic concept has 3 levels of schema of the database model, the levels. You have external level, you have conceptual level, you have internal level. What are these 3 levels? The external level is the view of users of the database. The conceptual level is the design of the database carried by the database administrator. Tables and primary keys and foreign keys. The internal level is how data is stored on the hard disk. So this is the external level. You have a program and contract view. What is contract view? The view the people in the contract department will see. Publicity view, the view for example, public. Finance view, for example, for the finance department. Recruitment view, for example, in the HR department. Okay, so this is the external level, and this is the views. We call this the external level that define the views, different views for different users of the database. Then the conceptual level is how the database is designed from the inside, and this is the responsibility of the database administrator. Then the internal level is how data is physically stored on the hard disk, and this is maybe part of the operating system can carry this. So what is the external level? Individual views of the database, how users see the database, because you can have different views for different departments, and this is called the external level. The conceptual level describes the database seen by the application, making use of the database. The description level views which users of the database might not see. For example, if the table is in the design view. Okay, this is in the conceptual level. Physical or internal level describe how data will be stored on the physical media. Maybe this is the duty of the operating system. What is logical schema? Logical schema describes the relationships between data and the structure. We have been creating a database with tables with one-to-many relationships. We also did entity relationship diagrams. All of these are called logical schema. Describes how the relationships will be implemented in the logical structure of the database. Shows the view of the database structure model. Model the problem by using methods such as ER, entity relationship diagram, independent of a particular DBMS. Okay, next, what are the features of the DBMS. DBMS is the database management software. There are few important features. We have data dictionary. Data dictionary is data about the data. So it is the properties of every table. For example, every table, how many fields in that table? What are the names of those fields? Which one of them is the primary key? And a little bit higher, the relationships between the tables. These are all in the data dictionary. The first and most important is the data dictionary, which is part of the database that is hidden from views from everyone except the database administrator. So the data dictionary is hidden from the view of all users and is only visible to the database administrator. It contains metadata. Metadata means data about data. This includes detail of all definitions of table, the table, field names, attributes, and the primary key, and also how physical data is stored. Data dictionary stores all information about the database, metadata, okay, for example, fields, data types, validation, and keys, and everything. Okay, again, data dictionary. Data dictionary stores metadata for the database. The data dictionary stores the all the information about the database. This is called data about data. Metadata about the data, for example, field data type and validation. Okay. Data stored in the data dictionary, table names, field names, also called attributes, data types, type of validation, primary key, foreign key, relationships. Index. Sometimes you need to index a field to use it in search, and you use it many times in search, so you need to use it to easily find what record you are looking for. So you create an index to make search using that index faster. There are a number of features to improve the performance of a database. One special note is the capability to create an index for a table. If, for example, you search the table using the primary key, then the primary key will be the index of that table. It is possible to have several indexes in the same table. So you search by many other fields. It is needed if the table contains a lot of data. An index is a secondary table which is associated with an attribute that has unique value. The index table contains the attribute value and pointers. It has pointers to location of data in the table that makes searching faster. To the corresponding tuple. Tuple means a record in the original table. The index can be on the primary key or on a secondary key. Okay, which was a candidate key. A secondary key is the index must be on something unique. Okay, searching an index table is much quicker than searching the full table. So there is kind of indexing to make searching faster. Security. Finally, these are all duties of the or features of the database management system. So what are the other features? Security, user account and access right, views, automatic backup, query processor, developer interface, planning a backup procedure for the database, and then we end with the structure query language. Security, finally, the database controls security issues, which include setting access rights for user, implementing backup procedure, ensuring that an interrupt database transaction will not leave the database in an undefined state. Okay. User accounts. strict actions, read and write, for specific users, so unauthorized users cannot access the database. Views restrict which part of the database specific users can see. Password, biometric, or PIN code to prevent unauthorized access. Automatic backup, create regular copies of the data to protect in case of data loss. Encryption, so data is incomprehensible for unauthorized use. The query processor, we will study now the SQL, the structured query language. Okay, the query processor is the machine, is the software that runs the query and produces the relevant data. A query processor allows developer to extract data from the database. The user enters the criteria, which is the search conditions, searches for data which meets the enter criteria, organizes the result to be displayed, to create SQL queries. We will be studying very soon SQL query to perform a calculation on extracted data. We already told everything about this. The developer interface. The developer interface enables a developer to create user-friendly forms and reports. User-friendly features such as forms to enter new data. So you can create a report, you can create a query, you can create a form. Output, report, in interactive feature like buttons and menus. Planning a backup procedure for data. How often? Maybe a backup at the end of every day. What medium? Maybe you create a backup on a magnetic tape, for example, if the data is big. Where should you put the backup? Maybe off-site, in another building. In case of natural disaster, the building is not destroyed with the computer and the backup of the data. What to backup? Maybe only update the data that has changed. When should the backup take place? Maybe at midnight, when no users are using the system. Who is responsible? The database administrator. Make sure the procedure is written and understood by staff. Otherwise, some data may be lost. Okay? So this is all about the database. The only thing left, and it is very interesting and very important, the SQL, the structure query language. It's a kind of programming language used to define the database and also to add data to the database and also to run queries, search, to get output and result from the database. You need that language when you create a database for a website, because the website will search in the database and a recorded. You will not be using Access at that time. So this is called SQL, structure query language. Is a language used to create a database, create tables in that database, create fields and set field data types. Okay. So SQL is the programming language provided by a database management system to support all of the operations associated with a relational database. Even when a database package often high-level facility, they use SQL. So for example, if you are using Access and you create a query, you can go to the SQL view and see there's some code written in the background. You have two types of languages, or SQL is split into two different types. One of them called data definition language, the other is called data manipulation language. Data definition language called DDL, data manipulation language called DML. Data definition language, DDL, is the part of the SQL provided for creating or altering tables. Data manipulation language, DML, is used after the database is created. So, for example, create database, this is DDL. Create table, this is DDL. And in the table, you put the field names and the data types, this is DDL. Alter table and add a primary key, this is DDL. Alter table and add a foreign key, this is also DDL. Okay? So it is clear that data definition language is about creating the database, creating a table inside that database, defining field names inside the table, deciding the data types, integer or string or boolean for each field, and then deciding the primary key, deciding the foreign key, and the primary key foreign key pair defines the relationship. This is data definition language. Okay? And this is an example of a script in DDL to create a database. Okay? Next is data manipulation language. It has commands like insert into. This is about adding a record to the database. So you decide or design the database using data definition language, and then you populate the table and add records to that table using data manipulation language, DML. Okay, so you have insert into. And the last thing, select, is the most popular. This is the search condition. Data manipulation language commands that start with select is about finding relevant records from the database. Okay, let us go through them and end with this chapter very soon, inshallah. Okay, okay. So the following are some examples of DDL, data definition language, that could be used to create the database for the theater agency. So create database and you give the name of the database and then semicolon. Create table band. So create table all capital and the table name is called band. Okay, and band name is one field. Varchar means it is characters between 25, that means it has 25 records, I'm sorry, 25 characters reserved for it. And here is a comma, because this is a list of field names. Number of members, it is number and 1. Here is a semicolon, because it is the end of the definition of the create table. And then alter table band, add primary key. So you are deciding now that band name will be the primary key. Alter table band booking and foreign key, band name, references, band name. So band name, so this is band in this table, and this is the other table, and this is the foreign key. These examples show that once the database has been created, the data table can be created and the attributes defined. It is also possible to define primary key and foreign key within the create table, but alter table can be used to show this can also be used. So that was an example about data definition language. What about data manipulation language? Data manipulation is about adding a record, deleting a record, or finding a record using SQL structure query length. Data manipulation language is used after the database is created to populate the tables with data. It can then be used for ongoing maintenance. The following code shows selection of the use of the command. There are two methods to insert data. First, the simple, you say insert into, and this is the name of the table, and this is the data, and it goes to corresponding fields in the table. Alternatively, you can say insert into and say band name, and this will get computer kids, and booking ID will get this value. So these are the field names, and these will be the values to go into that field name. Anyhow, data manipulation language is about adding and manipulating data in the table. The last thing to say is that select. And you did select, this is SQL, you did select in the O-level computer science. The main use of data manipulation language is to obtain data. You put a search condition and get the result. Using a query always starts with that select command. For example, select a single table. So select band name. So these are all the fields in the table band name. No, select band name. This is the field name from band. This is the name of the table. Order by band name. So you put them into ascending order. Select from a single table to produce an order list of all the bands. So as you can notice here, there is no where. There is no where. That where that defines the search criteria. So select, and this is the field that will appear in the result. From, and this is the name of the table. Where order by, this is order by band name, so the results will be in ascending order according to band name. To produce a list of bands that have headlined a gig, which mean headlining equal Y, the group by restriction ensure that the band name is not repeated. So select the band name from band dash booking where headlining equal yes. This is the criteria. Group by band name. So make sure if there are bands that are repeated, just group them into one name. Select from two tables. So select venue or date from booking where band dash booking dot booking ID. So equal booking dot booking ID. So now you have created a link to another table. So your main table is booking. Booking dot booking ID. So the booking ID in the booking is linked to the booking ID in the band dash booking table. This is the relationship. And the dot used here to indicate that this is a field inside that table. And band dash booking dot band name equal computer kids. This is the search criteria. Note the use of full names of attribute. This is the full name of attribute. It's not only booking ID, because we have to specify booking ID in which table, because here we are dealing with multiple tables. So this is the full name, which includes the table name. The query, find the venue and date. These are the results of the search. For band equal computer kids, this is the criteria. Okay, example. Create table file. To create table fields, this is using data definition language. So create table fields using DDL. Select film ID from fields. This is DML, data manipulation, because you want to search or get output. Alter table films and primary key. This is data definition language. Create database. This is also data definition. Let us go through this last question and the rest will be on the classify. In the company, an employee can be a manager. A department can have several managers and several employees. An employee can only belong to one department. The employees database has 3 tables. Employee underscore data, so employee ID, first name, last name, date of birth, gender, department number. Department, it has department number and department name. Department manager, this is department number, employee ID, and role. And then you were asked to draw the data entity relationship diagram. You were asked to draw the ER diagram. So, for example, this is department. Department. Here, department number. Here, department number. Department manager belongs to a department. And as a department may have several managers, this is the many side. So department may have many managers. Also, a department may have many employees. So it links to the employee data, and this many side, this is the many side. So the department links to employee data, the department links to the department manager. Also, department manager and employee, okay, this is one-to-one relationship because it will be between employee ID and employee ID. Okay, it will be between employee ID and employee ID, and here it is unique, here it is unique. So employee data, employee ID will link here to department manager employee ID. So if you can successfully draw this data entry diagram, you get the box. The employee database is fully normalized because. So this design is very good. It's in the third normal form. There is no repeating groups. There is no partial dependency. There is no non-key dependency, which means in the first normal form, because there are no repeating groups, it is also in the second normal form because no partial key dependencies. There is no joint primary key. No, it is in the third normal form, no non-key dependencies. Everything depends on the primary. Okay, so this is the table. Data definition language, DDL. Statements to create the employee database. So first create database employees, semicolon. And to define the table employee data. Next, create table employee data and open the bracket. Employee ID, you list here all the field names and decide their data types. Varchar means text because char is a character. They usually call text here varchar. Okay. Date of birth, so employee ID, first name, last name, they are all varchar. Between bracket 7, because all employee IDs are 7 characters in length. First name and last name, they vary. That's why they don't have number of characters here. Date of birth is data type date. Gender, it may be male or female, so the maximum number of characters is 6. No, between brackets 6. Department number varchar 2, S1, S2. Primary key, employee ID. The employee ID will be the primary key of that table. See, this is the data definition language to create a database and to create a table, set attributes, field names, and data types of that table. And this is an example of data definition language, DDL. Next, data manipulation, DML, statement to return the first name and last name. So you write select first name, comma last name. These are the return columns of all female employee. So you have gender equal female. In the Department of Finance, so where department of name equal finance. Okay. However, this is across two tables. You are dealing from employee data and department data. So department number equal employee data department number. This is the inner link or the relationship between the two tables. Thank you so much. We have reached the end of this chapter.